How was it, room?
That wasn't too good. All right, so we're getting ready up here. We're getting our WUE in order. So for those of you, who are ready for that. Should have brought my sunglasses. I had no idea the light was so bright up here. Looks like it's just about time. They're closing up the doors. Well, good afternoon, everyone. We're gonna kick this off here just a couple minutes early to get things rolling. We can see a little timer down here. It's resetting the time of the universe, so the atomic clock is going. We're here to talk about big data, and just to let all of you in the audience know, my name is Jack Pouchet. I'm on the board of directors of the Green Grid, representing Emerson. I can spell big data. I can actually spell Hadoop, and I'm here to tell you.
How do you spell it?
No, don't put me on the spot now with the camera rolling. Usually, and I had the great pleasure last year of going on a wild Hadoop hunt in Arizona desert, and I actually happened to see some Hadoop clusters, which was really quite eye-opening. And they were located on the rooftop in Phoenix. So it was, I won't say any more than that because then I'll give away who it was. But with that as a background, I'm not an expert on it. That's literally as much as I know about big data. But we've brought some industry experts here to share with you in a panel discussion. So I have some questions teased up if you are embarrassed to ask them from the audience. But I know our normal audience members are not too shy about asking questions. So this is to be interactive. But joining me immediately to my left is Paula from eBay. And then I'm going to allow them to introduce themselves and tell you why they're the experts to be up here, not me. Then Michael with EMC and Steve with IBM. So gentlemen, if you'll just take a moment to introduce yourself, a little bit about what you do, how it relates to big data, and you know why you're up here today doing this, and I'm just asking the questions. Go ahead.
Great. Hi, I'm Steve Brodsky from IBM. Thanks very much for having us. So I'm a distinguished engineer and technical executive at IBM, which means that I've been able to help be part of this really exciting initiative that we call big data. And in big data, we have both a software and a hardware aspect to it. The software aspect starts with something that people have heard of a lot, Hadoop. H-A-D-O-O-P?
That's what I thought. That's what I thought.
Just checking.
Yeah, thanks.
So,
that's how it's
and so Hadoop is a key open source software that is probably the most famous. It has the MapReduce algorithms, but it's not just there. It is really about how do you make these new technologies and new capabilities be effective and useful, not just for software and hardware, but also for our partners. We have a lot of different partners that we've been working with, and I'll talk about how we've been able to make it so that different organizations and different companies have been able to benefit from big data. We produce software that works very closely with hardware, and that works in both a real-time aspect, we call that streaming, as well as a batch processing aspect, which is based on Hadoop.
Either one, they should
Either
pick
one
it.
should
Yeah,
work. Okay.
there you go.
Can you hear me?
Yeah.
My name's Michael Howard. I'm a vice president at the Green Plum division of EMC, which centers itself solely on big data, Hadoop, and different aspects of big data that will make it more accessible to the general public, applications and data science. So to me, in essence, big data is about technology. It's making large volumes of interesting data accessible to all types of people, and it's also in combination to data science. Now, I've gone back many years in terms of analytics. I was the vice president of data warehousing at Oracle. I started a number of companies as CEO and chairman in this space. So for the last God knows how many years, I've been seeing the use of information as a way of creating new value, new opportunity for companies. And we're just at the embryonic stage of this new movement, which will really, in my mind, and I'm not exaggerating, will change the very fabric of the technologies used and how we all use data and how it impacts our daily lives.
I'm Paula Madurese. So I'm the director for database engineering at eBay. So the cluster he was talking about on the rooftop in the desert, that's us, right? So I've been with eBay for about 11 years. So I tell people I joined when I was 20-something with absolutely no gray hair, and I've got hair, but it's kind of turning its color.
Don't look at my gray hair.
I lead a few teams. I mean, all of transactional platform, which is like site-facing, like your transactional data when you look for an item or when you bid for an item, right? And then I also run some of the analytics. So the data gets in, and then you do a lot of analysis on top of it, and then to get some of the business insights that are valuable to how the product should be redesigned. So I have like spectrum of both the transactional side of the house and also the analytics side of the house. We are one of the biggest Hadoop shops in the industry, probably have one of the largest clusters in the world. So we live in it, we breathe it, we operate it, we automate it, and have a lot of fun with it. So, and enabling business at the end of the day.
So for our audience and certainly for my own benefit, I'll tease up a couple of the early questions. And we're here to talk about big data. So if you could share with us, what is big data? How do you define it? How does it differ from medium or regular data? And I know what small data is because that's like my checkbook. Okay, I got that understood. But we hear big data. So what is it exactly? How do you define big data?
Right. Well, the most traditional definition is around 3 V's, which is volume, variety, and velocity. And if you don't mind, I'd like to give an example of each of these 3 V's. So volume is the most easy to understand. That's where people's concept of big has around number of bytes of data. There's more and more prefixes, as we obviously know about, mega, giga, tera. After that, there's peta. And eventually it gets up to zeta, which is 10 to the 24th. And after that, they decided not even to create new prefixes. To give an example, if you had digitized all the sound of human speech throughout history, that's about a zettabyte. Also, the internet, as about 5 years ago, was considered to be about a zettabyte of information. To give an example of variety, that is information of many, many different kinds. And so, for example, with variety, if you saw the game show Jeopardy! About a year and a half ago, that was where there was a computer called Watson, which was a grand challenge, which was, can a computer take big data and analyze that data and play against the top champions of the game show's 27 years on basically general information, general knowledge questions. And so by taking things like almanacs, sports pages, encyclopedias, all this general style of information, doing tremendous amounts of analytics and machine learning, be able to answer questions, which we call deep Q&A, that were actually relevant and spoken in regular English. That's an example of how variety, which traditionally computers had not been able to address, is actually now becoming applicable because of big data. And then the last example is velocity, the rate at which information comes in. As everybody has seen, the rate of information arriving, whether it's through sensors, cell phones, text messages, social media, transactions in stock markets and commodities, the information set that's coming along is growing very, very quickly. And through velocity, having real-time processing of the information as it comes along, you're able to also make sense of what's happening. And so these 3 different dimensions, variety, velocity, and volume, are actually quite complementary. And very often, you can take a first guess, is it a big data problem, to see whether or not any of those 3 apply.
All right. Mike?
So, great academic definition. I mean, so apropos for IBM. No. Come on, I got to start a little bit.
Sounds like it's going to be a fun panel. Here we go.
Exactly, when you talk about big data, the 3 V's are really the first thing that comes to mind. And just to be a little different about it, there's always been, I mean, a volume of data is always relative to something. So it could be cost, it could be something else. So I kind of think that the notion of volume is irrelevant in terms of the definition of big data. So the way I kind of think about it is the distinction between traditional data warehousing and big data simply is this. Are you using it to create a new top-line opportunity for your company? And because I think the technical definitions of velocity and variety and volume are not as strong as what you're trying to do with the information. So in my book, it's about creating new opportunities for your company. It's about creating new products. It's not about counting things or doing a virtual close for your company's quarter. That's something that traditional data warehousing did. And traditional data warehousing had volume, it had velocity, it had variety to a certain degree. Although the distinction today, I think variety is a big one, is that if you think about all the social media data, whether it be from LinkedIn, whether it be from Facebook, whether it's the stuff coming from eBay, that does distinguish big data as a term at least in regard to traditional data warehousing.
Right. Yeah, I was going to, so I think that's a great definition. In fact, I'll explain it is in the context of eBay on all those three dimensions, right? So the volume for eBay, we were talking like hundreds of petabytes. So we're already like at that scale. And from velocity, we get a lot of incoming stream. Like, so things happen on the site, like from bidding or listing or checkouts, right? So all the data flows real time from the transactional platform into the analytics. So we have the velocity of the data coming into some of our analytics infrastructure. And then the variety, so there are some simple, very structured data, like transactions, very simple data types, and then there are semi-structured and unstructured. So we have even like some of the images, right, that getting into the Hadoop cluster. So we have all those three dimensions, but what I also echo is, okay, so you have all this data, like petabytes of data running on tens of thousands of compute cores, right? Pretty heavy distributed system. So how do you make sense of that data, right? Because at the end of the day, you can have like 500 petabytes, but if you're not pulling the key insights out of it, then it's of no use, right? So, and which we'll talk about a little bit more, how we are leveraging that data. So certainly the 3 V's is important, and so we have gazillions of the data, and in fact, we have thousands of internal users within eBay that leverage the big data that we have and to pull some of the insights that are so valuable to the company. And when we're transforming some of the eBay products based on the insights that come out of our big data platforms.
Yeah, I appreciate all that. So that in my mind, teases up a couple different directions, a couple items that I actually have good notes on here. Glad we discussed this earlier. So 2 different dynamics. One is, and I don't want to address this one yet, I'm going to come to it, but the one is going to be, how does a big data center differ from or do they differ from a traditional data center? And what do we need to know as data center designers, builders, operators, et cetera? We're going to come to that. Because the other thing I found, which is interesting, which is a conversation we don't hear often in here, is analytics and analysis. Okay, because we're used to running data centers, like you mentioned, closing month end, running transactions, you got stock options. Of course, Monte Carlo modeling is a little different animal as well. But so we're hearing analytics, and so talk to us, talk to our audience about analytics. How does somebody get it to become a data center scientist or a big data scientist? Is that something the CIA and FBI do, and we should be careful? We probably should be anyway. So the analytics side, that's different. It's not what a lot of us deal with. Talk to us about that industry. Are there career opportunities that could be coming forward from this?
Start with me or?
Go ahead. Start here.
Change it up.
Change it up.
So yeah, I think that's a great question. I think the data scientist role is quickly becoming one of the best jobs on the planet Earth now.
There you go. You heard it.
And And then there's a lot about it because a data scientist in the context of the top executives can be your hero, right? And all you can do is like bring one insight out from your data that can transform your company. And we have some of those examples, right? So the data scientist is like, okay, how do you make sense of these hundreds of petabytes of data that you have, right? And then it comes about how is the data stored, right? So the data scientists need to understand how to interact with the big data as well. So there's, in fact, in the context of Hadoop, there's an entire spectrum of the ecosystem that's evolving, like meaning the data access tools that the data scientists can leverage to pull the insights from out of your platform. So, and we have such a great heroes of data scientists in our company, and in the eyes of CEO, I mean, this is great because there are new revenue opportunities, new profitability models from the company, right? And how you can even design your, change your end user experience, right? And all that is coming from a lot of analysis that some of these data analysts and the data scientists do. So in my mind, they are the consumers of the data and making sense of the data and providing valuable information. So it's one of the very interesting career opportunities emerging in the industry.
Headhunters in the audience, take note.
You know, so we have a group of about 50 data scientists, and they're characterized by people who are both, let's say, perhaps a PhD in some functional area like immunology. And they're also able to write very complex SQL, or at the same time be able to use such tools as SAS or R for statistical analysis. So we're talking about a profile of a person who has a very, very high caliber, very, very different than, let's say, a database administrator for Oracle, or even someone who puts together the storage array for Hadoop, okay? So now there are arguments out there that does a data scientist have to have a PhD in some functional area? Right. That's arguable, or are they just naturally, you know, curious about and innovative about a given subject? But one of the examples I give that I think is tremendous, we worked with a healthcare company called CareCore, and they help hospitals with different ways of dealing with government and patients in terms of invoicing. And the government recently changed that anyone who acquires an infection in a hospital will no longer get subsidized from the federal government. So if you can take a group of data scientists with patient information over a number of years and be able to predict, and here's where this word predict is very, predictive analysis is very important. If they can predict the attributes of a patient when they come into a hospital and how should I say, curtail the possibility of getting an infection of in a hospital, that can change many dynamics. So it's about predictive analysis that the data science team does, leveraging a whole bunch of talents.
There's a wide range of people who could be considered data scientists, because data scientist is a term that in some cases is usually considered both a very technical role, and also there's a new general approach towards describing data scientists. So on a very, very narrow role, if you remember the TV show Numbers a little while ago, that's where the brother of an FBI agent was basically able to use various different data techniques to solve crimes. Now that was, the techniques that they used were real, even though the show was obviously fiction. The main thing that in fact actually they were missing in there was that they didn't really always have the data. In reality, did they have the data to actually make that show real? Had they had the data, though, it would have been more interesting. Now, as in other extreme, domain experts actually are becoming more and more often partially considered data scientists. So for example, at the University of Ontario Hospital in Toronto, there is a premature baby unit, intensive care unit, where babies are born very early, and obviously they're hooked up to a lot of different machines. Now, each machine, for good reasons, is completely isolated from all the others because you wouldn't want the machines that do oxygen, carbon dioxide, heart rate, all these to relate to each other. But on the other hand, there are certain things like the onset of infection which can be predicted by the combination of these sensors. And so one of the ways, for example, that we've helped with big data is in real time bring together the sensor readings from all these different systems, and the doctor there found the right algorithm that in fact did the data science work to find the prediction of infection up to 24 hours in advance. And obviously with these very little babies, their immune system is not very strong. And so what you can get from 24 hours is really a way to save lives. And so when these combinations of sensors, heart rate, blood pressure, et cetera, met certain criteria, it would bring over a medical professional. And so what you have is in one case, you can have some very, very sophisticated people who know a lot about analysis, or you can have more domain experts who really understand what is their data about and what is it telling them, and then finding a way to use that. And so it really helps span the range between traditional and the new kinds of opportunities for people to use analytics to make their own work better.
So a question I would have is, I'm hearing obviously some pretty massive number crunching and some ability to look through reams of data in very, very quick order and then be intelligence to act upon it. What does that mean for the data center? Do you have a purpose-built data center, or, well, I know eBay cluster happens to be in unique buildings, but I mean, that's your model, but is the data center different? What is different about it? Sounds like there's an awful lot of storage, maybe more than an enterprise data center would have. So how is a big data center different, and do we have to manage it differently?
I think there's a couple aspects to that. One is that the actual machines in big data typically are set up a little bit differently. There's a new concept which we call function to data. You have all your data together in one place. And the new way of doing it is bringing the function, the things you want to analyze, over to the data and analyze them where the data is. So that means, in effect, the data is really, in a sense, the king. The functions, what do you want to analyze, how do you want to do classification, how do you do insight across this information, pushing that out to the data in parallel and allow that very large number of machines in a data center to, in parallel, help find the answer. That's something that is a little bit unique, that makes a data center different in terms of its physical configurations. But there's also another point in that you can use the data center and the big data capabilities to actually make the overall world of the data center better. So one of the ways that we've helped is analyzing the power usage not only of the data centers but of the grid, the smart meters, to find ways in which you can help optimize the usage, whether it's the actual usage of the data in the data center or the people who are also consuming power from the same utility. Finding ways to reduce that power, reduce the usage of that power, very much helps make the overall data center more green.
That's good. Any other insights on the differences in data centers?
Well,
maybe the storage.
It's a pretty large topic,
Yeah.
right?
Well,
and I'm trying to decide which one I want to talk about right now. But so let me do, since I'm trying to be a little off the cuff here, there was an interesting 70-page article about taking YouTube data and putting it on an Oracle rack system, okay? And this 70-page, so imagine that, you have this data center and you have a massive amount of Oracle Exalogic or Exadata type servers or on rack, and how much would that cost? Well, to put YouTube up, just one instantiation of YouTube was something in the order of, for a year, about $600 million. Okay? Well, that could be cheap.
Just had some expensive videos.
I don't know. I mean, who knows how much IBM charges for things? But no. but then what it did is, interesting look, it compared it to open source and commodity storage.
Yeah, right.
Okay? And the difference was like something about 115 million versus 600 million a year.
Okay.
So when I think of a data center, And I think of the riveting changes that Hadoop and new technologies bring forth. It's so startling because the cost factors are so different, and the resiliency and the use of storage is so different that you know, it's apples and oranges. That's not to say, however, and I'll gladly listen, that Hadoop sucks in some ways. You know, in terms of storage utilization, I mean, name node resilience, the various of incomplete aspects of it, you know, need a horrific amount of human mitigation. So, you know, the data center for big data is evolving big time, whether it's physical, whether it's upstairs in the cloud. Let it go with that.
Yeah.
Thank you for acknowledging my nightmares, right? So Hadoop HBase operating those clusters is not easy. I mean, once you have like large clusters, it has its own challenges, but thanks for acknowledging that. I live that pain every day, right? So back on the data center topic, right? In my view, especially in the context of the Hadoop clusters, it's making the data centers actually more simpler, right? So if I consider Oracle systems and like a lot of these distinct storage areas and like, so they're like disparate hardware types, and managing all that within a data center is not easy. So one of the things that, for example, what Hadoop is doing is we roll that platform on thousands and thousands of homogeneous hardware, right? Okay. So from a data center perspective, I mean, it looks like racks and probably hundreds of them with simple switched and network architecture. So in my view, it's actually making some of the data center much simpler, and the economics of it is actually working out much better. Comparable to, like if you have to store the same data and you have to do the same analysis on a comparable Oracle system versus like Hadoop system, and the economics overall, both from infrastructure and from the data center, there's a great story with the big data.
You know, the other aspect I think that we're all kind of figuring out now is, will big data be something up in the cloud, or is it going to be behind our firewall? So for those of you who are taking sensor data, you know, in networks or, you know, in government institutions or over, you know, there's going to be a sensitivity about relegating it within the firewall, and so the data center that will affect the design of the data center.
Right.
With that said, though, if you know, like what Google and Amazon are doing, right, and we have some stuff too, you kind of won't know what the data center is all about. You'll just have a set of services that you'll employ to build your application that may use all this variety and volume and high velocity data. So I think it's a very interesting set of times that we're going through, because, you know, even though there's such popularity in the cloud, I'm not sure that people actually want to do the analysis up in the cloud in the big data world. So the data center is in flux.
That's true.
Yes, well, actually, we find that there's really three patterns. There is the traditional, the company has a set data center that is not necessarily cloud-like. The other extreme is what we call public cloud. Amazon is the most famous, but there's a large number of providers of the open public cloud. There's also what's called private cloud, which is where you do a cloud-like infrastructure. You manage it as if it is a cloud, but it's your cloud and not other people's cloud. One of the reasons why the public cloud is not necessarily always the best is the proximity of getting the data in and the relationship between the data that the company already owns and the new data that arrives. It's often in the space between where you take your existing data that you already have plus the new data and combine it to provide new value. To give an example, if you have a set of customers and then you have social media about those customers, you want to find out, are those customers happy or unhappy with your products? So you're combining the social media information with your own customer list. To do that, you would not necessarily be putting your customer list out in the cloud. You'd be more likely to go the other way, run, say, a private cloud where you provide your own enterprise information with the information from external sources. And often the place where the most interesting things happen is that combination between enterprise data and new data sources and analyzing those together.
If I may add one comment on the public versus private cloud, right? So in the context of eBay, for example, I cannot see, at least in the foreseeable future, that we hold or pump our data into a public cloud that's managed or hosted by somebody else. Because one, the data proximity becomes extremely important. And even more importantly, it opens a big can of worms, right, from a security perspective, right? So, and first, I mean, are we comfortable putting your mission critical data on public clouds, right? So, a lot of like the data proximity and security things, a lot of work that still needs to be done in order to seamlessly move between the different clouds, right? Public clouds that are hosted by some companies, and then the private clouds that the companies run by themselves, right? So there's a lot of work to be done.
I'm going to argue with that one just for the heck of it. You know,
It's a good panel.
I put something together called EMC On Demand. Before coming to Greenplum and working on big data, I put an on-demand, you know, kind of private public cloud for certain technologies for EMC. And what I found when I did a study on security, I found that there was more security, actually, in having the applications up in the cloud circumscribed by certain security measures that were bubble wrapped from the internet. So if you think about, all right, every one of you who works in an organization, you know, goes onto Google, is hooked up to the internet, you know, uses Flash at times, uses Explorer, some kind of internet, you know, right? And that's where the malware and the polymorphic stuff comes into play. But if you bubble wrap your data in applications up in the cloud, because it doesn't need to get into the internet, it can have a very secure pipe into it, it actually statistically is more secure. So what I'm saying here is that we're also doing mind games on this thing here. We think that the networks are slow to pump the data up. We think that there's less security up there. But in reality, it's just a new world. I mean, eBay and PayPal, no one thought they would ever buy stuff on the internet. And now look, I mean, you know what I mean, right? It's completely changed.
Yeah.
I'll take some of those things offline.
Yeah. So, but you have all kind of walked into a topic of security, which, you know, for those of us who spent an awful lot of years, most of our career in the data center space, you know, we know that, you know, in the early days, the whole thing was about 2n+1 or 2n+2 redundancy, resiliency, you know, building these things basically in almost nuke-proof bunkers, and the whole mindset and the philosophy of having a very robust data center also extrapolated out to the security measures that were used for the data center, for how you ran it, who came in, who went out. Same thing with the data. So I don't see our government liaison person in the room for Green Grid, but Congress has taken a look at this, and not only the U.S. government, but European government agencies as well have rules in place about data and who owns it and who, you know, transferring across different international borders, et cetera. But so recently, and I know we talked about this before coming in here, and it's all kind of new to all of us, but so Congress is kicking around, for those of you in the room, it's called CISPA, C-I-S-P-A. So Cyber Intelligence Sharing and Protection Act. An act hasn't gone into law yet, but just reading between the lines and what we see on it, you know, this might be the next HIPAA coming into the data center space, okay? And so, you know, you all kind of teased up that discussion of security, but security and privacy of big data. Because what I think about is, you know, you talk about velocity, variety, and volume. And so, you know, there's tons of data that we're putting out there when we do eBay or Facebook or Yahoo or any of these sites. We're putting out a ton of data out there, and as an industry, you know, what are your thoughts on this? And more importantly, since this is a Green Grid group, is something we should be taking a look at. Should we have some participation as Green Grid in this broader discussion? So whoever would like to lead off.
Well, it's a good point. There is a sort of a paraphrasing a phrase is, with great data comes great responsibility.
Yeah, that's good.
That's a good
So if you are going to analyze across all this data, what's called data governance becomes extremely important. You have to know how this data is treated. And in many cases, for example, in the health industry, as you were mentioning, you can't actually move the data across jurisdictional lines, independent of whether or not there's a better data center in another jurisdiction. The data has to stay in effect where it is. And so making sure that the data is managed properly is very important. And there's a term called data lineage, which means that if you're going to have a result, how do you know where it comes from? So being able to trace back where did the data come from, how did it get there, what analysis was done is very important. And that opens up, on one hand, an opportunity to actually manage your data better. The related thing is, how can big data itself help make data more secure? When the 9/11 incident happened, actually, IBM Research helped create a set of real-time network analysis technologies to help in the event that there are more cyber events. And as we are seeing more and more often, cyber events are becoming more and more common. And the ability to monitor networks to make sure that things like denial of service incidents are able to be defended against, in some cases even tracked down, that requires a significant ability to process information in real time as well as in aggregate. And so one of the uses of big data is actually to help create defenses against cyber attacks, and then overall make all the data centers more secure.
Good. Other perspectives? eBay, you're dealing with a lot of private information.
Yeah. I was gonna say I echo some of his sentiments. Basically, what happens is, so we do collect a lot of external data. After all, folks are using our platforms for payments, right? Or they're buying stuff from eBay, right? So we do collect a lot of the data, and some of them are users' data, and some of them are more transactional and accounts type of data, right? So there's a lot of policies and governance around it, what we do with the data. So although we have that, it does not mean that we can do anything with it, right? So to his point, yes, I mean, it stays within the confines of our responsibility, and also what we do with it. There are very strict policies and guidelines. So,
Good. Mike, did you have anything else? Or?
No, I think you guys,
Okay.
yeah.
So there are probably some pressing questions that the audience has. There we go, Phil. Thank you for not leaving me hanging here. But I didn't finish my intro to that. No, go ahead. If you have any, let's get those questions out there before we run out of time, because I want to hear what's of interest to you with regards to big data.
Yeah, so a combination of comments and questions. Question, and maybe specifically to eBay, but across the board. With respect to what it does to the data center, eBay went through a huge standardization of SKUs, really trying to minimize them, but you can't get rid of the difference between a general compute SKU and a Hadoop SKU. Right, you got down to 2 SKUs, and Hadoop causes you to have functionally another SKU. It has a different power envelope, it has a different weight envelope, it has a different cooling envelope. So in terms of the data center, it has an impact. Comments about that, and as well as, for you, it's actually less dense. For most data centers, going to big data is actually getting more dense. They have this haphazard alignment of 2 or 3 kilowatts per rack, and all of a sudden they have an 8 kilowatt rack. What's it doing to weight density? I mean, if a data center can handle 800 kilograms per square meter, is it going to overcome that? If they only can generally supply 3 or 4 kilowatts per square meter, what's the actual impact that you're seeing there? And then on moving the data around, or moving the application to the data, do you see a bifurcation of some data living out in, like Amazon has the genome database, and they got the astronomy database, and Google has the books database, and LexisNexis has the law database. How do you start combining all that without moving data around? I mean, do you write applications now that go out and live on all these clouds and then come back with your data?
So yeah, I'll take the first eBay context question. So I'll share however much I can. So The distinct hardware SKU is a challenge. So let me start off there, right? Because we do have a lot of like different applications, and Hadoop is only, think of it as just one application, and which is becoming much larger in scope. But if you look at it, we have traditional SAM arrays, right? And that has a very different network architecture, different even footprint, and different like space, power draw, right? So we have within our data centers all this disparate infrastructure hanging around, right? And when I said it's actually making it simpler, we are consciously taking some serious effort into consolidating to the extent possible, right? So that we can have, it has on the infrastructure side, right? And the less number of SKUs, it's better because one, you can use the same SKU between different applications, so you can move the compute or storage and the memory around, right? So there's a lot of effort that's going on to get to some consolidation. But having said that, the reality of the data centers today, they do house distinct infrastructure, and it is a challenge, right? And also it depends on, we do have like multiple data centers, so we kind of manage it from different perspectives. But certainly trying to consolidate on few hardware SKUs that makes the management much simpler.
I'm not an expert here, but what I do see some of my customers asking us about is where does virtualization come in the density therein? Mm-hmm. So, for example, I don't know if you've heard of something called Serengeti, in HVE, which allows these essentially to run Hadoop in a virtualized environment, and therefore you get the physical and logical constructs a little bit different there, and that seems to be from a SKU point of view or whatever in the minds of many. So that's what I see happening.
The usage of the hardware is actually really important. And to give an analogy to virtualization, if you think about it, before virtualization, virtual machines, you were finding that a lot of times there'd be certain physical machines that were underutilized. Virtual machines and better management of the applications enabled people to keep the average usage much, much higher. And so I think that with big data, the mindset from the softwares from the beginning has been about increasing the utilization rate of those machines to a much higher degree than had necessarily been the case with traditional space. So what that means in effect is that the machines may, because say they have a lot more storage and hard drives, initially look like they're using more density in terms of power, but you may be able to push more analysis and more applications through them to help balance that out. The overall, the higher level concepts of managing your data center and pushing the maximum amount of analysis through your overall system may be able to actually make it so that you're not any less efficient, possibly more efficient, because you're operating closer to the data in many cases.
I think you had another part of your question was sort of a federated question, which was, where are we going in terms of federating data, whether it be all in one place or distributed. And where I see, let's say, the global 3000 going is not exactly that. I mean, again, just my particular perspective is that Hadoop looks like this. Sometimes Paula Madurese call it a data lake or a data landing zone, where all data comes. It's almost like an operational data store of sorts, where you put everything together and then you create your different applications off that. So I actually, even though the industry gurus are talking more about federation than ever before, and you have something called JSON, I don't know, JavaScript object notation, which is sort of this new, in my sense, almost like a new format for all data that makes federation even that much easier. So that's my take on it, that actually Hadoop is actually making people think in consolidation forms than the other way.
Mm-hmm. Yeah, but as we noted before, there are some data policies and security policies that I think you'll see government, regional governance differences, saying that if you have a data center in Germany, and your data is residing there, that if somebody from Italy wants to run some analytics on it, they can access it in Germany.
Yeah.
They can run the query in Germany, but they cannot bring the data over to Italy, and run the analytics there. I think you mentioned that before.
Yeah.
We have about a minute left. Another question from the audience. Here we go. Big data, little time. Go.
Thanks. I'd like to know if any of you think that big data will justify a specialized data center.
From an Emerson perspective, we always like new data centers, so
Well,
I
I
can
think
answer that.
that it will have a lot to do with the value that you can derive from processing the data. So to just give a famous example, if you can analyze the data, and if you know about Moore's law, that's where hardware doubles basically every 18 months in terms of performance. So if you were to say, I'm going to make a product in 2 years, this product has to be how much faster? Twice as fast to keep up with the competition. Now, if you were to make it faster than that, then you'd have some advantage. So if you can use the data center to produce predictions which provide value, for example, if you were the only one that knew Moore's law, you were the only organization, you could then set where you need to be in a couple years, and you'd have a tremendous advantage. If you have that kind of economic advantage, you're able to distill what's most likely to happen, predicting the future from your analysis of data, then that kind of benefit would justify data centers and the use of more and more big data within your data centers.
Thank you.
Okay, well, on that note, I'd like to thank our panelists. We'll stick around for, oh, okay. Well, yeah, we're always building new data centers, right?
Yeah.
Exactly. Right,
Yeah.
right. Yeah.
Yeah, absolutely.
Yeah, no, it's clear. No, the industry is driving
It's
needs for
purpose-built.
more data centers.
Yeah.
So again, I want to thank Paula, Mike, and Steve, our panelists, and thank you to our audience. Appreciate it.
Thank you.
There's a networking break taking place in the foyer now.